Hello students, and welcome to part 2 of Unit 7 Part 1 Lesson 1, where we're introducing the systems of linear equations. So right now, this statement in front of us is telling us what it means to find solutions. Well, when we say we want to find the solution, we are also saying that we want to solve the system of linear equations. So anytime you hear solve the system of linear equations, that means to find the solution or solutions. There are 5 different ways to solve systems of linear equations. The first, which is we call in context, and maybe you would call guess and check, is a good strategy to get you started, but when there's infinitely many different order pairs to choose from, this could be a very monotonous process, especially sometimes when there's no solution at all. So you would try many options to find that there's none of them that work anyway. So guess and check is not the best strategy, but it is a strategy that is especially useful if you have a solution that you want to check, and we'll talk about that in a little bit. The second one, which we will actually learn in our next lesson, is solving by graphing, but there are also substitution and elimination that we will learn in part 2. The last is using a matrix, which is a very neat way of solving systems, but is more useful when you have 3 or 4 or more variables that you're working with, which we only work with 2. So we will not be setting a matrix, but I would like you to know that that is one of the tools that you have in your toolbox to solve a system. So I'm going to give you an example of a system that has one solution. I'm even telling you the solution. So if you know a solution that you want to try, you can substitute these values in to see if they make both the equations true. So let's start with the first equation. Y is equal to x plus 2. So our y value is 12. So we have 12 is equal to 10 plus 2. Is 12 equal to 10 plus 2? Yes. So this is a solution to the first equation. Now we got to try it in the second. 2y minus x equals 14. So 2 times 12 minus 10, does that equal 14? Well, 2 times 12 is 24. Is 24 minus 10 14? Yes. So 10, 12 is a solution. This is one value of the variable that will make this equation true. Now, this is an example of a system that has infinitely many solutions. There are infinitely many that will make these both true. So for example, let's try the order pair 4, 3. Y is equal to x minus 1. So is 3 equal to 4 minus 1? 4 minus 1 is 3, so yes. Let's try in the second one. 2 times y is equal to 2 times x minus 2. So 2 times 3 is equal to 2 times 4 minus 2. So is 6 equal to 8 minus 2? Yes, so this order pair makes this true. But check out this order pair, 5, 4. Do you think it will make it true as well? So y is equal to x minus 1. Is 4 equal to 5 minus 1? Yes. What about in the second equation? We have 2y equals 2x minus 2. So we have 2 times 5, 2 times 4. Got to substitute y in there. Y value second. 2 times 4 is equal to 2 times 5 minus 2. Is 8 equal to 10 minus 2? Yes. So there is another one that will make it true. And there would be infinitely many more because these two are called coinciding lines, which we'll learn about in next lesson, but I'm just trying to give you a preview to that word. So we can see that there are infinitely many. 6, 5 would make it true. 7, 6 will make it true. And any that follow that pattern. Now, here's the opposite. This is a system where there is no solution. You can never find an ordered pair that will make these both true. So for example, let's substitute 2 in here. 2 times 2 is 4, plus 3 is 7. So the ordered pair 2, 7 will make this first one true. But try substituting that in here. Is 7 equal to 2 times 2, which is 4, plus 5? Is 7 equal to 9? No. So even though it's a solution to the first one, it's not a solution to the second one. And I just gave you one example, but you could try every single ordered pair and that would always happen. Here's why. If you have a certain amount of money and someone else has the same amount, and you each double your money, but the first person gets to add 3 and the second person gets to add 5, will you ever have the same amount? No, because you constantly increased by the same amount, but had a different extra value. This will never have a solution. You can try every ordered pair, it will never work. So if someone asks you, how many solutions does a system have, you would have to say, well, it depends. Sometimes there's one solution, which happens most of the time. Sometimes there's infinitely many solutions. You can pick from any of the ordered pairs on the line. And sometimes there's no solution. There's no ordered pair that could ever make both of them true. So if we want to get to a solution like the solutions that we just talked about, we must first write a system of linear equations. To write a system of linear equations, there's 2 steps. First, identify and define your variables, and second, write 2 or more equations to describe the variables in the situation. So let's look at an example. Lillian has a choice of 2 long-distance telephone plans. The first has a monthly fee of $3.95 plus 5 cents per minute. The second plan has no monthly fee, but charges 7 cents per minute. For how many minutes will the plans cost the same? What will this cost be? So you can see by the questions there's 2 amounts we don't know. We don't know how many minutes and we don't know the cost. Well, the number of minutes that you use will affect the cost of the phone bill. Now, let's write an equation describing x and y for the first plan. So the total cost will equal $3.95 plus 5 cents, 0.05 per, that means multiply, minutes. There's our first equation for our system. Our second one is going to describe the second plan. So the total cost is equal to, there's no monthly fee, but there's 7 cents, 0.07 per minute. So times x. These 2 equations represent the comparison between the 2 plans. The first equation represents the first plan, the second equation represents the second plan. Try one more example. Ben and Barb are brother and sister. They both have savings accounts at the bank. Ben currently has $46 in his account and saves $2 per week. Barb currently has $10 in her account but saves $4 per week. After how many weeks will both siblings have the same amount of money? To represent this situation, we first need to define our variables. X is going to be the number of weeks each person has been saving money, and Y is going to be the total in the account. Okay, we will have 2 equations, one for Ben and one for Barb. So let's start with Ben. Ben currently has, so that's y equals $46 in his account, and so that's plus, saves $2 per, which is multiplication, week, which is x. Now let's go on to Barb. Barb has, so y equals $10 in her account, so that's 10, but saves, so that's adds $4 per, which is multiplication, week, which is x. So these two equations represent the comparison between Ben and Barb. So let's now summarize what we've learned. Our first focus skill was what is a system of linear equations, and a system is two or more equations that represent a real-world relationship. Our second was what is a solution to a system of linear equations, and a solution is any ordered pair x, y that will make all the equations true, which is both the equations in our case since we'll only be looking at two equations. Third, what types of solutions exist to a system of linear equations? And there are three different types. There could be one solution, and that's what we call consistent and independent solution. There could be infinitely many solutions, which is what we call consistent and dependent solution. Or there could be no solution at all, an inconsistent solution. Our fourth essential question or focus skill was, what are the 5 ways that a system of linear equations can be solved? We can solve a system by guessing and checking. We can solve by graphing, substitution, or elimination. Or we can use a matrix, which we will not study this year, but is a great way of solving a system if it has 3 or more equations. And last, how can I write a system of linear equations for a real-world situation? Well, first identify and define your variables, and then write 2 or more equations to describe the variables in the situation.